Hi guys, happy Monday. I hope you guys have had a wonderful weekend. I hope your first week of e-learning went well. I would love for you guys to be able to tell me how it went. You can either message me on Canvas, you can email me, or I even have a discussion board for all of the 8th graders where you guys can chat and talk about what's going on, how e-learning is going. And I'd love to know your feedback and how it's going. So please message me and let me know how e-learning is going. So today we're going to focus on combustion reactions. Combustion reactions are probably one of the easiest type of reactions to identify. So at this time, go ahead and get out your interactive notebook if you haven't already, and you're going to label the top of the page or the next clean page, combustion reaction notes. So go ahead and do that now. Okay, now that you have labeled your interactive notebook, we're going to go ahead and dive into notes. It's only 2 slides, not a whole lot of info, but it's pretty important. So go ahead and start taking notes as I talk. So combustion reactions occur when a compound or an element with oxygen release energy and produce carbon dioxide. So sometimes this is referred to as a hydrocarbon combustion, and that's because CH, okay, is called hydrocarbon. So it doesn't matter how many atoms there are of carbon, it doesn't matter how many atoms there are of hydrogen, this is called hydrocarbon because we have hydrogen and we have carbon. So in a combustion reaction, the formula looks pretty much the same every single time. So we have some type of variable of C and H. So we can have any number of C, we can have any number of H, as long as we have carbon and hydrogen bonded together. It doesn't matter how many we have of each, but we have at least a hydrocarbon plus oxygen gas. So every single time in a combustion reaction, you're going to have a hydrocarbon and oxygen gas. And then when you add energy, which could be in the source of light, heat, or electricity, you are going to get carbon dioxide and water every single time. You will have carbon dioxide and water in every single combustion reaction. You will have carbon dioxide and water. Now, you could end up with 4 molecules of carbon dioxide and 2 molecules of water. Or you could end up with 10 molecules of carbon dioxide and 10 molecules of water. Either way, you still have carbon dioxide and you still have water. So this is the general equation for combustion reactions. I'm not going to click on this link right here. There is a link to this PowerPoint in Canvas, and so you can go in and watch that reaction right there. It's really cool to watch. So X and Y represent integers. Okay, so this again could represent any number of carbon. It could represent any number of hydrogen. X and Y are integers or variables to represent any number that could potentially be there. So let's talk about some examples. So one is a natural gas, methane, is burned in a furnace to heat homes. This is a common combustion reaction. It's a real life combustion reaction. This happens all the time. If you live in an older home, I grew up in a home where we used methane gas to be burned in furnaces, and it heated our home. And so that equation looks like this: CH4, which is methane gas, plus oxygen gas. When you add energy, it produces carbon dioxide, water, and then energy is actually released. That's the heat that is in the homes. So not only are you adding energy, but energy is also being produced in combustion reactions. Sometimes they're endothermic, sometimes they're exothermic, and we're going to be talking about that next time. But in this example, the whole reason why we do this combustion reaction in the home is to heat it, because heat is being released. So that's that energy being released. Another example is acetylene torch is used to weld metals together. So there's a picture of that right there. As you can see, so welding metals is basically taking 2 metals and melting them together to create, so that they're combined and they create one thing. So here we have a hydrocarbon, 2C2H2 plus 5O2 yields 4CO2 plus 2H2O. So we have our hydrocarbon, we have carbon and hydrogen, we have our oxygen gas. When we added energy, we got carbon dioxide, water, and energy was released. And you can see in this picture, energy is being released. You can see all the sparks flying. It was probably really, really warm if you were to hold your hands around the heat being produced right here. So that's that energy that's being produced. It's the heat after the reaction or during the reaction has occurred. But it's not the energy that you add, it's the energy that is being produced, because this is on the product side. Another example is carbohydrates like glucose, so sugar, combined with oxygen in our body to release energy. So we obviously eat a lot of things with sugar in them. Here is our hydrocarbon. Now you'll notice that there is actually oxygen in this hydrocarbon. Remember what we talked about at the very, very beginning of this unit. The only three elements that are going to be in a combustion reaction are carbon, hydrogen, and oxygen. So even though this equation looks a little different, we have an oxygen here alongside with our hydrocarbon, we didn't up here, that's okay. Because as long as we have these three elements within a combustion reaction, it is still considered a combustion reaction. So we have C6H12O6. So this is actually the formula for glucose or sugar. C6H12O6 is sugar. Plus 6O2 yields 6CO2 plus 6H2O. And then, of course, energy is being released. So in this real-life example, we have sugar and oxygen because we inhale oxygen. Our body needs oxygen. All of our cells in our body need oxygen. So sugar and oxygen combined with energy from our body produces carbon dioxide and water, and then energy for our body to be released so that we can have energy. So we can get carbohydrates like sugar by eating, right? That's why we eat in the first place. We need to give our body a lot of energy to be able to move and to function, and we need to give our cells the energy to do their part. So that's where our energy comes from, is from the food we eat. So that is all for today. At this time, you are going to complete your combustion Nearpod lab and reaction notes. Have a great day, guys.